So I'll just share one thing before we get started. So one of the learners who we taught, I would like to share his story. So he was a software engineer who used to work with TCS, but he was very sincere, had very good orientation, very hardworking, and he used to just study for 1 hour each day. But his 1 hour each day was so consistent that if I kind of looked at his heat map, it was completely green, green,
Oh,
green, green,
yeah.
green. And because of that consistent effort, in a span of 6 months, his problem solving ability had, increased impeccably. Eventually, he got an offer at Amazon, and currently he works with Amazon as a software developer. But the key thing over here is element of consistency. Cool. So the theme of today is going to be intro to pre-computation. It is basically a technique through which you can optimize so many algorithms and so many solutions, right? And it is a pretty useful technique, to be honest. Now, let me give you a very simple example of what pre-computation is, like how you can probably think about it. So let's say you are standing here along with your mom, and your mom is, let's say, doing some work. Maybe she is making some rangoli, and she needs colors for those, right? So she tells you that, hey, can you just go and grab a green color, grab a packet of green color. So what you can do is you can just go look into the drawer, get a pack of green color, come back, hand it over to your mom. And then after 5 minutes, your mom can say that, hey, keep it back. And this time bring me another packet of red color. So you'll go back, get red color, give it to mom, and then again, mom could ask for some other color after 5 seconds, 10 seconds. So you will have to constantly go, bring, give, go, bring, give. This is what you will have to keep on doing on a repeat mode. Now, a better way than this could have been that when you go for the first time, you can grab all the colors. So let's say you have grabbed all the colors with you. And when mom asks for, let's say, blue color, you can hand over blue color. When she asks for green, you can hand over green color. So what you have done is you have performed some pre-computation. That pre-computation was of this form that you went and instead of just picking one small pouch, you picked the entire carton of colors. Yeah, that must have taken a lot of time because instead of picking just one small pouch, you were carrying a carton. So maybe carrying it, bringing it all the way could have taken some time. But after having taken that time, the subsequent queries of mom are very easy to answer. So that is what happens. That's the trade-off, right? So, you get something, you lose something. So if you perform some pre-computation, during that pre-computation phase, while performing it, you might have to do some extra work. But why you are doing that extra work? With the faith that in future queries will be answered very swiftly. I mean, you will not have to just go back, come back, go back, come back. You have everything at your disposal and you can answer all the queries instantly. That's the idea. So this is a real world thing, and inspired on that, there are techniques which we can use to optimize our code. A very simple example. Let's take a super simple example. Let's say somebody tells you that, hey, there is an array which contains some elements inside it. So let's say 2, 1, 3, 0, 4, 5. Okay. And then there are some queries. Every query is of format I comma j. Okay. I and j, they are indices of the array. Okay. So for example, your query could be something like maybe 2 comma 4. So in this case, what you have to do is from index 2, which is this, to index 4, which is this, whatever is the sum, you have to return that. So from index 2 till index 4, the sum is 3 plus 0 plus 4, which is 7. So the answer to this query is 7. Now let's say there is another query which is of form 0 comma 3. So it means that from index 0 till index 3, which is this, 0, 1, 2, 3. I have to tell the sum. So what is the sum of this part? It is 2 plus 1 plus 3, which is 6. So I need to return 6. So if this is the question which is thrown to you in an interview, or let's say maybe in your online coding round, wherever it is, that you have an array whose size is n, and then there are q queries. Every query is of form I comma j, and you have to tell the sum from I to j. How would you go about it? What could be the brute force way of handling this question? So the brute force way could be super simple, where you would say that, hey, for every query, I'll write a loop, and that loop will go from I to j, and then sum up the elements and return that sum. So of course, that's a correct approach, right? That's definitely correct. But is that efficient enough? So we will check that out. So if you're using this approach, then how much time are you taking to entertain each query? I mean, each query is being answered in how long time? So you would say that, hey, let's say there was a query which was of form 0, comma n minus 1. Now, because you are looping, the time taken over here would have been order of n. So I can say in the worst case, a query could end up taking order n time. And now if there are q queries, my time complexity will be q multiplied by n. So this is the time complexity, and this might give me TLE if n and q both are very high, let's say around 10 power 6. If the number of elements in the array is 10 power 6 and number of queries is also 10 power 6, it will give you TLE for sure, because this product is 10 power 12, and 10 power 12 CPU cycles, no, it will not fit within the time limit of most of the code judges that are out there, right? So can we do something better? So here we will come up with a very simple pre-computation. That's the simplest form of pre-computation. And I'm talking about it so that everybody at least comes on the same page. Some of you even mentioned about that, but let me just reiterate it. So guys, just think of it in this manner. Let us say you have an array, and now you are storing something called as cumulative sum. Cumulative sum can also be referred to as prefix sum. Prefix sum, as the name says, sum of a particular prefix. So let's say you know what is the sum from here till here. Let's say this is index I. And you also know what is the sum from here all the way till here. This is index j. If you know that, can you quickly find the sum of this part, which is from index I till index j? Is it possible to find that out? It's super easy, because what I can say is that if this much of sum is known, then I just need to subtract this much of sum from that. Then my job will be done. Super simple, right? So I can just say, let's say if I had an array, and let's say it contained 2, 1, 3, 4, 0, 6, something like this, right? If you know the sum from here till here, what is that? 2 plus 1, which is 3, 6, 10, plus 0, 10. So the sum till here is 10. And now if you know the sum till here, what is the sum till here? It is 2 plus 1, which is 3. If you do 10 minus 3, 10 is denoting the sum of this part, right? And 3 is denoting the sum of this part. So if you subtract it, you will end up getting the sum of this part. So 10 minus 3 will be 7, and it will denote the sum of this particular part. That is the idea. So from here, I can deduce that if I know that what is the sum ending at index j, let's say this is index j, and what is the sum ending at index I minus 1. Mind it, not I minus 1. Because this index was 1, and subtracting this much of sum gave you the sum from 2 all the way till this index. So if I know the sum ending at j, and if I know the sum ending at I minus 1, then just by subtracting those values, I can get the sum of this sandwich part. So basically, if I have to generalize it, I would say, let there be an expression ps of I. ps of I is basically the prefix sum from index 0 till I. Then I can say that sum of the segment, which is from I to j, can easily be written as prefix sum till j minus prefix sum till I minus 1. Now what it means? Given that I have created this array of prefix sums, I can answer every query in constant time, in order one time. Because all that it takes me to do is to just subtract this and that. Now I am no longer running a for loop for this purpose. Now, having understood this idea, we would now talk about how to create this prefix sum array. I would say, guys, it is the easiest thing to do, right? Because if somebody has given you the sum from here to here, if that sum is s, and let's say this element is 10, then what will this sum be? Nothing but s plus 10. So what I can say is that if this index is I, then prefix sum of I is simply equal to prefix sum of I minus 1, which is the sum of this much part, plus this new element, which is nothing but A of I. So this way I can create a prefix sum array, and it is super easy for me to create that, right? So, I mean, if you think about writing the code, it would be a very, very easy thing to do. I mean, you can just get started with an array of size n, and you can always declare ps of 0 as array of 0, because the prefix sum from here to here is just this element. And now you can write a for loop for I equals to 1 all the way to n minus 1. And you can just say ps of I is equals to ps of I minus 1 plus a of I. This step that we have performed over here is pre-computation. And now, what is the time complexity of this? I mean, what is the time complexity of this step? So if you take a look, the time complexity of this is order of n. So my pre-computation time is order of n. And now queries will be bombarded at me, right? Every query will be of form I comma j, and I will have to give the sum. And I know that by using this formula, I can return that sum in order one time. So for each query, I can entertain it in order one time. So if there are q queries, all of them will be entertained in order of q time. So what does it mean? It means that now my time complexity is equal to pre-computation time plus query time. And what is query time? It is order q. So now it will be order of n plus q. And it is much, 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 much better than order of n into q, which was our old time complexity. So see, this is the benefit of pre-computation. I wanted to specifically touch upon it, that given that you have done some initial work, yes, that initial work took some time, but the benefit of that has been reaped while answering the queries. Because now for answering each query, I do not have to write the loop. I just can use that formula and return answer in constant time. As simple as that. So this is the benefit of pre-computation. Another signal that I would want to give you guys is, if you see any coding question which says things like these, that there will be some queries and you have to very efficiently process those queries, chances are very high that it might be linked to the idea of pre-computation. Okay, not always, but most of the times it might be linked to, I mean, more than 90% of the times it would be linked to pre-computation. Okay, we will take another question as an example. How many of you know about XOR, exclusive OR? So what is XOR? It is nothing but a bitwise operation. So let's say there is a bit B1 and then there is another bit B2. You can do their XOR, and the result of XOR depends upon what their values were. So if there are two bits which are exactly the same, then the result of XOR will be 0. But if both of them are different, if the first bit is 1 and second is 0, or first is 0 and second is 1, then the result will be 1. So that's the simple rule for XOR. Now, if there are few more important things about XOR, I mean, so if let's say you take two numbers and you are taking their XOR, let's say your first number is 9 and second number is 9. If you are taking their XOR, how does it really happen? It happens bit by bit. So what is the binary representation of 9? How do you write it? You write it as 1, 0, 0, 1, right? This is 1 and that is 2, 4, 8. Yeah. So if you are taking XOR of a bit sequence, it happens bit by bit. So you take XOR of this and this, you take XOR of this and this, you take XOR of this and this, and you take XOR of this and this, and I'm 100% sure the result will be 0. Because if you are taking XOR of the same number with itself, this and this will be exactly the same, and the result will be 0. So it's a very important that if you are taking XOR of a number num with itself, be ready to get a result as 0, right? Okay, this is one property. There are few more simple properties. So one property says that if you are taking XOR of a number with 0, you are going to get that number itself. And it makes absolute sense. Just think about it. Let's say this number was anything, any random thing. Let's say 1101, another 0. If you're taking its XOR with 0, let's write 5 zeros. What is going to happen? We know that everything here will be 0 because it's a 0, right? And if at a certain position I had 1, I am 100% sure at the corresponding position over here, I would have 0. And the result of that XOR is going to be 1. Similarly, here I have 1. So I'm 100% sure here there will be a 0. And the result of that is going to be 1. If there is a 0 here, I am 100% sure over there also there will be a 0. So the result will be 0. So wherever you will have 1, you will have 1. Wherever you will have 0, you will have 0. So basically what it means is if you are taking XOR of a number with 0, you are going to get the same number itself. Okay, I'm just enumerating these properties so that when we discuss a question, you can perfectly relate to it. One more thing, just like you can rearrange the additions and multiplications, you can rearrange XOR operation also. So what I mean by that is if A plus B plus C can be written as A plus C plus B or B plus C plus A, same thing can be done with XOR. I mean, A XOR B XOR C can also be written as this or any permutation, right? You can just do that. Okay, having learned this, now switch to a question. And the question is that we have an array containing some integers, let's say 2, 1, 5, 7, 3, 6, something like this. Okay, now again, you have been thrown a lot of queries, and every query is of format I, comma j. And you have to tell the XOR of elements from index I to index j. In other words, you have to tell the value of AI XOR AI plus 1, XOR AI plus 2, so on XOR aj. So see, it's just like the last question. In the last question, you had to tell the sum from I to j. Here, you have to tell the XOR of values from index I to index j. So let's say if your index I is 1 and index j is 4. So this is index 1 and this is index 4. So basically you have to tell the XOR of, you have to tell 1 XOR, 5 XOR, 7 XOR, 3, whatever that value is that you have to return. If you remember, if you really remember the last question, we had written an expression that, yeah, we wrote it here. That sum from I to j is basically prefix sum till j minus prefix sum till I minus 1. If instead of taking prefix sum, this time you take prefix XORs, will it be helpful in some way? Let us say you have an array. This is your array, and it contains some elements like A, B, C, D, E, F, G, and H. All right. Somebody gave you two indices I and J and told you that, hey, tell me the XOR from index I to index J. Let us say this is your index I and that is your index J, right? Now, if you have pre-computed the prefix XOR, which is ending at index J. So if you know the XOR from here to here, by the way, what will that value be? It will be A XOR B, XOR C, XOR D, XOR E, XOR F, right? Now, if you also know the XOR from here to here, what will that be? By the way, it will be A, XOR B, XOR C. Now, if you take a XOR, if you take a XOR of this with that, tell me what is going to happen. You can see that this A and this A will cancel out, right? Because A XOR A is 0. B will cancel out. C will cancel out. So this entire thing will cancel out that entire thing. It will become 0. So what will we get is it will be 0 XOR D XOR E XOR F. And we all know that if we are taking XOR of anything with 0, that is same as that thing. So actually what we will end up getting would be nothing but XOR of these elements, which are from index I to index j. Now if you look carefully what happened, while you found out the prefix XOR ending at index j, it contained A, B, C. And when you found out the prefix XOR ending at index I minus 1, it again contained ABC. So the contribution of ABC got completely erased, got completely removed because ABC was part of this prefix also and ABC was part of this prefix also. So what you are left over with is just this part, DEF, and that is what your answer is. So it is going to be exactly similar where I would say that, hey, if you want to entertain this query I comma j, and if you have computed prefix XOR ending at j, and you also know prefix XOR ending at I minus 1, just take their XOR. And that will be equal to the XOR of this subarray, which is from index I all the way till index j. So this was just another very much relatable example. Now what we'll do is we'll take a question. So just read the question, and this question was asked in one of the recent contests, I believe. So those of you who are regularly participating in contests and all might have solved it. Yeah, looks like one of you has solved it. Okay, so first let's understand the problem. And then most of you should be able to think much more. The question basically says, first it talks about the notion of parity. Parity, you can understand it as even or odd. So let's say there are two numbers, 4 and 20. Both of them have same parity because both of them are even. But if you have 7 and 12, both of them have different parity. So here they have different parity because one of them is odd and the other is even. Similarly, if it would have been something like 8 comma 1, this also has different parity. Now, if you read this question talks about special array. So it says that something is a special array if all the pair of adjacent elements have different parity. Okay, all the pair of adjacent, that is what the question says, right? If all the pair of adjacent means left, right. Okay, so what it basically means is if I have an array where the first element is even, I want the next one to be odd. And then I want the next one to be even, then again odd, then again even. So alternating trend, this is what I want. So if you go by this, if you have an array like 6, 1, 8, 7, 10, is it a special array? Very much. Even, odd, even, odd, even. So this is a special array. But you know, your special array, instead of looking like this, could also have looked like this. Let's say if your first element was odd, it could have been followed by even, and then again odd, then again even, then again odd, then again even. It could have been like this also. So the trend could be basically anything. Now, in the given question, we are told that we have some input array. So let's say our input array looks like this. It contains 2, 1. Now, is this entire array a special array? The answer is no, because here you can see even, odd, and after odd, I would have wanted even, but it again is odd. So this entire array is not a special array. But now we are given some queries. Every query is of that format I comma j. And you just have to focus on this subarray. So just focus on this subarray and tell me if this particular subarray, which is from I to j index, is it special or not? If it is special, you should return true. If it is not special, you should return false. Let's take a quick example. Let us say your index I is 2. and your index j is 5. What is your index 2? This one. And what is your index 5? 3, 4, 5. This one. This array, can I regard it as a special array? Let's have a look. Odd, odd, even. Perfectly. Because it is odd, even. So I can perfectly say that this thing is a special array. So I should return true. And if it would not have been the case, I must have returned false. So that is what the question is. Right? Now, one way to solve this question is that brute force approach, where for every segment, you can say that, hey, what I'll do is, my approach will be very simple. I'll check if it maintains a trend of odd, even or not, or even odd or not. Now, if you perform that check, every query will be answered in n time because you will have to iterate from I to j. And the complexity will again become q into n, which is a lot. So can we do something better? Can we do something probably just a little better around it? A hint that I'll give you guys is think in terms of alternates. Think in terms of alternates. Or if you have any other approach also, because this question can be solved using multiple approaches. Okay. So if you have any other approach, you can share that too. You can just type it in the chat box. You can talk about it. All right. So guys, tell me one thing. Let's say you have an array. We'll take the same array as an example. 217694, 217694, and 101. Now, think of it in this manner. If we maintain the count of even numbers, we are calling it even count. Even count of I, it tells me the count of even numbers from 0 till I. Let's say it tells me the count of even numbers from 0 till I. So let's just take an example. Let's say this is your index I. How many even numbers are there from here till here? So this is even, and this is even. So the count over here will be 3. See, why I am thinking in terms of count is because if I have to inspect any subarray, let's say there is any subarray that I have to inspect. In this case, this was the subarray. Now here, what I wanted was that at this position and at this position, which are two positions. So at these two positions, there should be exactly two evens. And at this position and at this position, which are exactly two positions, there should be exactly two odds. So two even at these positions and two odd at that positions. So that is promoting me to think in terms of count of even numbers, that how many even numbers are there till index I. Then counting the number of even elements from 0 till I is not going to offer us much of help. Why it is not going to offer us much of help is because we know that here the game is of alternates. I gave you this hint at the very beginning. The game is of alternates. So I'll change this thing little bit and I'll write it in a different manner. I'll say that, hey, now this same thing tells me count of even numbers in index I minus 2, I minus 4, I minus 6. Do you see what I'm saying? All the way till the end. That how many even numbers are there till that index in an alternate fashion. In an alternate fashion. So basically, what I'm trying to say is, let's say if I had an array 2, 1, 5, 9, 6, 4. Then what must have been the value stored over here? The value stored over here would have been that how many even numbers are present till this index in an alternate fashion. So is this even? Yes. Is this even? No. Is this even? Yes. So the answer over here will be 2. That is what I'm saying. So the count of events till here will be 2. And those events are being considered in an alternate fashion. Similarly, if somebody asks me what will be the value stored over here at this index? Then I would say it will be equal to how many even numbers are present till this index in an alternate fashion. Do not forget about it. Alternate, because of alternate, I have written I, then I minus 2, then I minus 4. You can see I have skipped I minus 1, I minus 3, I minus 5, right? So how many even numbers are present till here in an alternate fashion? Is this even? Yes. Is this even? No. Is this even? No. So the count over here will be 1. That's what I'm trying to say. So before we proceed ahead, I would want to understand if all of you are with me on the same page. Do you understand? Do you clearly understand the definition of even count of I? So now, guys, think of it in this manner. Let's say you had this array. There were different elements. I'll just be writing down their indices. So this is your index 0, this is index 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, and 9. Okay. Now, somebody has given you a query. Okay. And that query, let's say, is 5 to 8. So he wants to know whether the array from 5 to 8, which is from here till here, whether this array is a special array or not. Now, if this thing is a special array, either I'll have even here, odd here, or odd here, even here. So let's talk about the case of having even here and even here, which makes odd here and odd here. So for that, I would want to have two odds in this range. I would want to have, I would want to have two events. I would want to have two events in this range. Now, how do I check? How do I concretely check whether I have two events in this range or not? So I can say that if even count of 8 is not known, if even count of 8 is known, that would account for this, 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 and this. Now from here, if I subtract one simple value, then that will give me that how many events are there in this range in an alternating fashion. What should that value be? Tell me. What should I subtract from here so that I get to know that how many events are there in this range starting here in an alternating fashion? It should be even count of something. What should that something be? If I subtract from here this thing, which is even count of 4, just see what is going to happen, because even count of 4 will consist of the count for this, and that. And that will be removed from even count of 8, and that way you will get the contribution of this part. Right? Because if you are interested in the contribution of this part, you have to subtract the contribution of that part. And the contribution of that part is hidden in even count of 4. So if I simply subtract even count of 8 minus even count of 4, and if that value is 2, if that value is 2, then I am 100% sure that at this position and at that position, the values which are present are even values. I am 100% sure about it. And the same thing can be done for checking for this as well as that, right? I can say that, hey, if I know the even count till index 7, let's say I know the even count till index 7. Now, even count till index 7 will comprise of the contribution of 7, 5, 3, and 1. Now from this, if I subtract one value, can you tell me what should that value be, which I should be subtracting from here? So if you have even count till 7, what is the value that you would want to subtract? You would want to subtract even count till, let's say you have known how many events are there till this index, till 3. So if you just subtract that, you will get the count of events here and here. And now, if you see that this value has returned you 2 and that value has returned you 0, What it means? It means that at this position and this position you have got even even, and at this position and that position you have got odd odd. Because those are odd, so the even count is 0, right? So this way what we are doing is we are doing a very simple thing. We are simply storing the prefix sums. Here the sum is not the sum of values, it is simply equal to the sum of the count of even numbers basically. So if we are just subtracting those values, then we are getting the contribution of alternating items. Alternating items. And then based on that, we are able to take a call if there are some required number of events here or not, and some required number of events, which is, I mean, 0. Like you would want that there are 2 events and 2 events in this part and 0 events in this part, or the reverse of it. What could be the reverse of it? 0 events in this part and 2 events in that part. So this is how you would have to go, right? Storing the prefix counts at alternating indices. See, if you know the even count in a range, and if you know how many elements are there in that range, so let's say there are 5 elements in a range and 2 of them are even, then how many of them will be odd? Let's say there are 5 elements in a range, 2 of them are even. How many of them will be odd? 5 minus 2, which is 3, right? So if you simply store the count of evens, you would know the count of odd. Because if there is a range from I to j in which there are 3 positions, 3 alternate positions, and out of those 3 alternate position, one value is, let's say, even, then you know that the remaining 2 values are odd. So if all the 3 are even, 0 are odd. And if none of them is even, all of them are odd. So you don't need to track odd count. You just track even count. By subtracting, you can get to know what the even count would be, right? So just to summarize this up, to summarize this, I would say if that's our array, and if I have to answer from index I to index j, whether this portion is a special array or not, then I would want to know that at index j, at index j minus 2, at index j minus 4, at all these alternating indexes, all the way till here, all the way from here till here, either I should have all even, or I should have all odd, right? So again, taking an example, if this is 3 and this is 8, right? Then I know for sure that even count of 8 will tell me that how many, events were there at indices 8, 6, 4, 2, 0. Now from here, if I subtract even count of 4, then that will tell me how many events were there at 4, 2, and 0. Now you can see this thing will be subtracted from here. And because of that, we will end up just seeing the contribution of 6 and 8, right? That is what you would want to see. Sorry, this is not 4, this is actually 2, right? Because this is before index 3, you have got 2. So it will subtract the contribution of 2 and 0. So basically this and this will be removed and you will have with yourself 8, 6, and 4. So you actually wanted the contribution of 8, 6, and 4. You wanted to know whether at index 8, index 6, index 4, which are 3 values, are there 3 events or not? So if this thing is equal to 3, you're 100% sure that this is even, and that is even. And the exact same thing can be repeated for this index. I mean, the leftover alternating ones. So if I zoom in this part from index 3 to index 8, this part, it is index 3, it is 4, it is 5, it is 6, it is 7, and it is 8. So you wanted even, even, even. Let's say you got those events. Now you want odd, odd, and odd to be here, right? So for that, what will you do? If you know how many events are there till here, which will be stored in even count of 7, from here, you would want to return minus a value. So we all know that even count till 7 will store that how many events were there at 7, 5, 3, 2, 1. Now from here, if I subtract one value, and what should that value be? It should be even count 1. Then what will happen? Sorry, not 2, 7, 5, 3, 1. We are alternating. Then this will just store the even count at index 1. Now, if you subtract this and this thing will go away. And now you would know the contribution of 7, 5, and 3, which is what you want. And if this thing is 0, I mean, if this thing is 0, that means there are 0 events at these positions. So if there are 0 events at these positions and there are 3 events at those positions, you are 100% sure that this is a special array. As simple as that, right? And the same thing can be done in reverse manner also. What I mean by reverse manner, it could have been that instead of even here, you had odd, 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 and you had even, even, even. So the both checks can be put. And putting both checks, you can quickly realize whether it is, a special array or it is not a special array. And now if the length of this segment is L, you know that the number of even elements will be L by 2 and the alternating set of indices will be L by 2 and L by 2 each. I mean, the first one could be L by 2 plus 1 also if the length of this is odd, right? So based on that, you can make a quick check and you can quickly return whether it's a special array or not. So the implementation of this might require some hard work in terms of putting some if-else conditions around it, but is the general idea clear? It is not very hard to code. It's actually easy to code. I mean, if you got it at the beginning when you try, see, one of the candidates, he told me after his Amazon interview that he was asked a question in which he was given Q queries. Every query was of form I comma j, and he had to tell that what is the sum from I to j in an alternate manner. So a of I plus a of I plus 2 plus a of I plus 4 plus a of I. So he had to tell the sum from I to j starting at I in an alternate manner. The same approach can be used there. The exact same approach can be used there. Yes or no? No, the time complexity will not be order n. Your pre-computation will happen in order n time, and then every query can be answered in constant time because you are just subtracting. See, you're just subtracting the even count till j minus even count till either I minus 1 or I minus 2, depending on some circumstances. And what are those circumstances? I'll quickly explain. Let me just show you the code. So let me quickly just show the code and then we will wrap it up. Yeah. So just last couple of minutes or so. So yeah, let's have a look. This is the function. Okay. So this is the function. The first thing we did is we created this array to store the even count ending at every index in an alternate fashion. First, I called this function precompute. So my function precompute is present over here. Okay. Now here, what should be the value of even count 0? Even count 0, just use your common sense. I mean, if you have an array like 3 comma something something something, the even count from here till here will be 0 if it is odd, and if it is even, then the even count from here to here should be what? 1, right? So that is what is written. This is just a ternary expression which says that if nums of 0 is even, then even count 0 will be 1, otherwise it will be 0. Now if the array is a bit longer, I mean, if the array is of size greater than 0, then I go ahead. I also initialize even count of 1 because see, if the value over here is 5, if this thing is odd, the even count over here should be 0. Otherwise, it should be 1. Let's say if it was 50, which is even, it should be 1. The same logic. Now from index 2 onwards, I can write normal logic. And what is that normal logic? It simply says that if, let's say the value over here is 62, which is your index 2. So you would say that the even count ending at index I will be equal to even count ending at index I minus 2, which is its alternate index, I minus 2. And if this thing is even, you will add the contribution of this to that. So that is what we have done. So even count at I is equal to even count at I minus 2, whatever even numbers we had till I minus 2. And if the current element is even, we are doing plus plus. Otherwise, we would not do that. If this thing was, let's say, odd, we would not have done this plus plus. So is this pre-compute section making sense to everyone? Yes or no? Let's move ahead. And now we are going to write the code to answer every query. So we are iterating on all the queries. So for every query, we have got X and Y. So we have to find the sum from X to Y. And now I'm just trying to find the sum in the range X to Y. Okay, so get me the sum in the range X to Y. So this is the function which is written for that. And this just handles some edge cases. And what are those edge cases? Let's understand. So let's say you had 1 and then you had 10, 4, 6, 5, 7, 8, 3, something like that. Okay. And let's say your first index was this, which is 0, 1, 2, 3. This is 4, then 5, then 6. Okay. And if you have to find the sum from, you have to check whether this thing is representing a special array or not. Then in that case, what I can do is I can say that, hey, let me check that how many even numbers are there till index 6. Okay. And now, if this thing has a different parity than 6, I mean, if this index is even and that index is odd, then in that case, what would I want to do? I would want to say that, hey, let me just subtract the value over here, which is at index 2. And it makes absolute sense, right? Because when you subtract even count of 2, then it will do away with the contribution of this and that, right? But if let's say it had the same parity, if instead of 3, let's say this value was 4. So you want to get 0, 1, 2, 3, 4. This was 4 and that was 6. So in this case, you'll have to be a bit careful because now you would say that I want to do even count of 6 minus even count of 4 minus 2, right? Because this 4 is included in your range. So this x minus 2 and x minus 1 that you are seeing is just to handle that. Is just to handle that if same parity, if both the indices are having same parity, then we would want to subtract even count till x minus 2, and if different parity, then even count till x minus 1. Of course, taking care of the fact that index is not getting negative, because if index is getting negative, then it's the entire count itself. So we don't want to subtract anything, we want to subtract 0. So this will get you the sum, just the even count in the range from, X to Y in an alternating fashion. So you get the first alternates, and then similarly, you can get the second alternates. Your second alternates, they start at Y minus 1 and they go back like Y minus 1, Y minus 3, Y minus 5, and so on and on. So the same logic is written for that from X till Y minus 1. Okay. And here one more check that, see, sometimes it can happen that X and Y both are the same. If X and Y both are the same, then there is no second set of alternates. You do not need to remove that second set of alternates. See, that corner case is pretty simple. That corner case is just that. So I asked a lot of you to implement on your own. When you implement, you will see what that corner case is. Because uh, like here, just take this example. If this is 4 and this is 6, even count at 6 will include the contribution of 6, 4, 2, and 0. Now you do not want to subtract 4. You want to subtract 2, right? But if let's say this thing was not 4, if this thing was 3, in this case, you want to subtract 3 minus 1. So when both are having the same parity, if both the indices are even, then you go for subtracting x minus 2, otherwise x minus 1. You understand this idea, right? Because if this index is 6, then it basically takes into account 6, 4, 2, 0. So if your x is 1, uh, not 1, let's say x is 3, you want to immediately subtract 3 minus 1, which is 2. right? But if, let's say, your x is 4, you want to subtract 4 minus 2, which is 2, right? So that's the only thing that you have to take care of, right? Because, okay, you can even, this is 4, and let's say that is 6. So when you talk about 6, that 6 encapsulates 6, 4, 2, and 0. Now, if you have to look at this range, what do you want to subtract from this? You want to subtract 2 and 0, right? If you want to subtract 2 and 0, what is this 2? This 2 is not x. This 2 is not x minus 1. This 2 is x minus 2, correct? So if this is also even and this is also even, then this even is going to be a part of this, right? So you don't want to remove it. You want to keep it. So you will do even count of y minus even count of x minus 2. That's what I'm trying to say. Okay. But on the other hand, if let's say this was 3, in that case, what would you do? In that case, you would want to do the same thing, but given that it is 3, it is having a different parity. Now it will be x minus 1. Because when it was 4, your 2 was at 4 minus 2. When this is 3, your 2 is at 3 minus 1, right? So if different parity, if you come in the else case, you subtract x minus 1. Otherwise, you subtract x minus 2. I mean, that is how the alternations happen, right? 10, 8, 6, 4, 2. And if your first number is odd number, then just x minus 1. And if your first number is even, then you go for that number minus 2. That's the entire idea. Okay, just try implementing it on your own. You will discover these edge cases, these small cases on your own. It's not pretty hard to figure that out. Could you relate to it? How many of you could relate a bit to it? That why this if else was needed? You will, eventually you will. When you write the expressions, eventually you will on your own. It's not that hard to look into it. And then that's it. Now, whatever your size of the range is, it'll have some length. So that length, L1 length is this. I had to take a seal because if let's say that length is 7, then one set of alternates will have 4 elements and another set of alternates will have 3 elements. But 7 is not even number, right? So one set of alternates will be 4 and the other will be 3. So the longer one is this L1 and the shorter one is this L2, which is total length minus L1. And now I am checking if all the events were found in first set of alternates and none of the events were found in second set. So either I'm looking for this where I had even starting from the beginning and the other set was odd, or this case. So it is just the reverse of that because you relate to it, right? Because you could either have set of alternates which are like even, odd, even, odd, even. It could also be odd, even, odd, right? So it automatically takes care of that. Putting this or and including this condition, it automatically takes care of that. So if this condition is true, we will do answer I equals to true, and then we'll return our answer. So that's the idea. Now, if you take a look, pre-computation took n time. This loop will run for q times if the size of this is q, and we are doing constant work. So here, whatever we are doing, little bit plus minus here and there, it's just constant work, right? Yeah, you can rephrase this code in different ways also. That's totally okay. As long as idea is the same, it would completely get accepted. There were few probably rearrangements that I could have done, but I wrote this code in little rush, so I did not get to do that. You guys can do it. And yeah, as I said, there are many other ways also to solve the same question. One way is using binary search. Another way is using pre-computation again. But I wanted to illustrate that how you can solve this question using what you just learned. Because see, problem solving is a lot about using the tools which you already have. You might not have tools which others have, but can you use your own set of tools and solve the same question in the same complexity? So you have to train your brain consistently for this thing.